Now, let's see. No. Cover K with this cover. So for every x in K, we had one of these dealies, right? There he was. So let's just buy ourselves a little space here and cut the epsilons in half. That's still an open set, still contains x. There's one for each x, so it certainly covers K, right? K is compact. How many of these do we need? Right now there's uncountably many. But we have a huge fact going for us. K is compact, which means by the Borel-Lobé criterion we can do what?
Find a finite subset.
Right, we can reduce it to a finite subset. That implies that there is a x sub I minus epsilon I over 2, x sub I plus epsilon I over 2, I running from 1 to n that covers K by compactness, right? So that's a huge benefit.
What's the subset? I is less than.
I is less than or equal to n, greater than or equal to 1. I'm sorry, is this?
Well, shorthand in Spanish.
Okay.
Well, it's been an hour and a half. Late, yeah.
Oh, you're behind. What have I done?
Well, you didn't present what you've done.
All right. Yes, you didn't want to offend the real people. All right. So we have a cover. We've extracted a finite subcover. All right. Now, define delta to be the min. I'm going to write it again here. The min over all the i's of the epsilon I over 2 will be related. I claim it's going to be the Lobé number for the cover. So what will nail this down? We have to pick a set where we have one point in it and then an arbitrary point within delta of it. And show that that's all inside one of these beasts, right? Would that do it? You know, what I'm trying to do is say, okay, here's an arbitrary point x, and then here's a point y. The distance between x and y is less than delta, and then it must be that they're all inside one of our super duper, one of these babies, right? And remember where these things are. They're inside the elements of the original cover. Hardly. It's looking really what? Oh, good. Did you do this in analysis? You showed that a Lobé number existed, or did you do?
No, they're just talking about open covers. Delta is less than.
Okay, good. Oh, I don't want to bore you.
No,
I'm glad to come in.
yeah, I'd like something I recognize.
Okay.
Then I don't think we're just talking about those pieces.
Okay. So delta is going to be the smallest of the epsilon i's that were given to us by compactness, right? Huh? Over 2 joules. Sorry. Yes. Okay. So now, suppose for arbitrary x, y such that that's true. In other words, the points are in a set, they're never more than delta apart. So all the points in some set here have the property that they're not ever more than delta apart. Need to show what? If x is in a particular, now x is a point of sorry. Given S subset of K with the length of S less than delta, we need to show S is contained in one of the original cover sets, right? Now, if S is less than delta, that means that X and Y in S implies this is true, right? Which is this line. I just wanted to start here instead of start right there. That's why I raised that. True? So S is a little set. Its total length is less than delta. So if X and Y are in it, it means they are not separated by more than delta. So what we have to do is show that S is wholly within one of the cover sets. Now, so we're almost there. Okay, X is in some X minus the xi minus ei over 2, xi plus ei over 2, because these as a group cover K, right? And X is in S, so X is in K, so X is in one of these, has to be. Huh? Yeah, we're just saying it's in the ith. Done if Y is in that, right? Because if Y is also in this one is in O alpha I, which was an original member of the company. Now, why would Y be in that if X minus Y is less than delta? Okay.
Delta was the mid of the epsilon I. Yeah. Delta was the mid of the epsilon I.
Epsilon I over 2. So the
Delta is C epsilon I over 2.
the distance between Y and xi less than epsilon I, not epsilon I over 2, means that Y is in this baby. And of course, remember way back when, I forget when, back here, This guy was in there. So